Now, chemists have been learning about atoms for a long time now, and so we've found lots of different types of atoms. Over 90 just naturally occur on Earth, but we've actually been able to make new atoms in the lab too. And as we have found out more about the different atoms and the different properties of those different atoms, we've been able to put them into this amazing table called the periodic table. And this is where we put all of the different atoms. So you would be familiar with some. Hydrogen is an atom. It's got one proton in its nucleus. Oxygen is a different type of atom. It's different because it's got 8 protons in its nucleus. Gold is a different type of atom. It's got 79 protons in its nucleus. Iron has got 26 protons in its nucleus. And so these are all arranged in this table. And if we look along the table here, we can see that hydrogen is first. It's got 1 proton in its nucleus. Helium is second. It's got 2 protons. Lithium has got 3 protons. Beryllium, 4. Boron, 5. Carbon, 6. Nitrogen, 7. Oxygen, 8. Fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. And so they are in order of the number of protons that are in their nucleus. We can also see different patterns in the periodic table though as well. If we look at the different periods, so these are, a period is a row of the periodic tables. There's period 1 and period 2. All the atoms in period 1, they only have electrons in their first electron shell. All the atoms in period 2, they have electrons in their first and second electron shell. In period 3, all of these atoms have electrons in their first and second and third electron shell. So these are the different periods. So 1, 2, 3, 4, 5. All these atoms have electrons in 6 electron shells. So these are the periods, these rows. We can also see that there are groups. So the groups are the columns of the periodic table, and all the atoms in the same group or column have very similar properties. So all of these atoms are quite reactive. If you mix lithium or sodium with water, they're quite reactive. If we go to the other side of the periodic table, we'll see that all these atoms, they're actually called noble gases. They're gases at room temperature. They're not very reactive at all. But different columns or different groups have the atoms have very similar properties, and so that's why we've organized it like that. So when we look at the periodic table, we actually also see that there's kind of some big trends across it. So we can see all these yellow atoms, these are all metals. And so metals are normally a solid at room temperature, except for mercury. They're shiny, they're good conductors of heat and electricity, so they've all got some very similar qualities. All of these blue ones over here, these are all non-metals, so these are all generally a gas, normally a gas at room temperature. There's some exceptions like bromine and iodine, but they are not good conductors of electricity. When they're solid, they're brittle. You can't bend them like you can metals. Again, they've got some, non-metals have some similar properties which are different to metals. And these green ones in the middle, these are all metalloids. So they've got some properties that are a little bit like metals and some properties which are a little bit like non-metals. So this is about the periodic table. We can see that there are big clusters of metals, non-metals, and metalloids in the middle. And we can also see that both the different rows of the periodic table, or the periods, have something in common, and the groups or the columns have something in common, and that's all about the periodic table and metals, non-metals, and metalloids.